Okay. So what we're going to talk about first is finding the degree of monomials. A monomial is a single term polynomial expression. Monomials, one term. And we look at these here, all of these here are a monomial. There's one term. There's one expression that are being multiplied together. Whenever we bring in addition or subtraction, we're adding two monomials or three monomials together. And we look at these here, so this here gives us some examples of things that are not monomials. So the first one is 5 plus x. A sum is not a monomial. This is actually going to be considered a binomial. And bi means what? Two. Like bicycle has two wheels. So this is a binomial because it has two terms. What do you think a trinomial would be? 3. Trinomial would be 3. This here is not a monomial. It's actually not a polynomial because we cannot have variables in the denominator. We can't have them in the bottom of a fraction. We can also not have variables as an exponent or negative exponents. None of these here would be monomials. Okay. Monomial is a single term with multiplication together, and we don't have variables in the bottom of the fraction or negative exponents. Now, the degree of a monomial, what we do is we take all of the exponents that the variables have in that term and add them together. Now, the question it might be, well, the first one is 10. There's not a variable with 10, correct? The degree is 0. Whenever there's not a variable written, it is automatically 0. Now, the next one we have, and it's already got the degree listed, we have 3x. Well, since there is not an exponent written with x, it is understood to be 1. So the degree would be 1. Now, if we look at the next one here, well, we have 1/2 ab squared. Well, a is to the first power. B is to the second power, so 1 plus 2 gives us 3. And the last one, we have m to the 5th, so the degree is 5. Okay, so let's look at some of these here. Find the degree of each monomial. So I shorthand degree by writing a capital letter D. So 5x squared. What is the degree of 5x squared? Because it's x squared, the only variable is x, and its degree is 2. So, because the exponent is 2. All right, let's look at letter B. What would the degree be for letter B? Negative 1/2 xy cubed. Do we have more than one variable? Well, yes, we have x and y, yes? So what are the exponents with x? 1. Because we take all of those exponents that are connected with the variables, we're not worried about the numbers, just the variables, and we add those together. 8x cubed, y cubed. 6 is one of the exponents is 3. The other is 3, and 3 and 3 gives us 6. Any questions on these so far? All right. What's the degree for this last one here? It wouldn't be -1 because all of our degrees is connected with the exponent with the variable. Yes? Is there a variable with -3? No. Zero. Right, this one here is tricky. Because anytime we don't have any variables, it's just a number. That's what we call a constant term. If it's just a number, it is the constant. So here, -3 would be the constant, and the degree of a constant is always 0. Here, I'll give you another one. This one's a little bit easier. How about the degree of 2x? Because this one here is a little bit nicer than -3. So we do have a variable this time, don't we? So it can't be 0, because if it is a number by itself without a variable, then it would be 0, yes. But here we have 2x, yes? So we're looking at what exponent goes along with our variable x. If there's not one written, it has to be 1. Because anything to the first power, if it's not written, exponents are always 1 if they're not written. Does that kind of make sense? Somewhere back there. Okay. All right, let's do the next one. 3/4 x squared y squared. What do you think about this one here? What would the degree be? Ready? What would the degree be? 4, because we would do 2 plus 2, which would give us 4. How about the next one? Because here it would be 2 plus 1, which would give us 3. And last but not least, -15. Would be? Anybody? 0. Number by itself, a constant term, it would be 0. So our degrees would be? And we're just adding those exponents with the variables. We're not too worried about the ones with the numbers. That's it. Now, the other thing we're going to talk about, and this is it here, a polynomial function. A polynomial function. Poly means what? Does anybody know what poly is? What is the meaning of the, if I'm remembering right, prefix, poly? Polymorphic. There's polygon, polynomial. Anybody have an idea what poly means? Yeah. It's many. Poly means many. Because so polynomial. So we're talking about more than one nomial, more than one of these polynomial terms. So as we talked about earlier, we have a binomial, which is 2, and we have a trinomial, which is 3. Now, when we write these in standard form, we're normally going to have a variable. We're normally going to talk about it in one variable, at least in here. We can talk about it in more than one with x, y, z. We can have multiple variables. But here we're going to mainly focus on one. And they always go from right to left, biggest to smallest, if it's in standard form. Biggest, the exponent with the biggest, the variable with the biggest exponent, not the exponent with the biggest variable. The variable with the biggest exponent goes first, and then the second one, then the third, and going down. And whichever variable has the biggest exponent, it is the degree. So here the biggest exponent is 3, so the degree is 3. And the number in front of it is the leading coefficient. It's the one that's leading it. And as we said, the term number by itself is a constant. So what we want to do is we're going to do 3 different things. One, we're going to write it in standard form. Then we're going to identify the degree and leading coefficient. So looking at this here, which variable has the biggest exponent out of these 3 here? It is the x to the third. So if we write it in standard form, it goes first, yes? And it would be negative x to the third. Because it's minus x to the third, the negative goes with it. So what variable has the next biggest exponent? Well, 15, yes. It'd be 15x. Yeah, I need to draw that a little better. And then what goes last? Plus 3. So this is in standard form because we have x to the third, x, constant term. It's always going to go in that decreasing order of powers. Now our degree for this here would be what? The degree is always going to be the biggest exponent. Since the biggest exponent for this here is 3, the degree is 3. Now the leading coefficient, I'm going to call it LC, leading coefficient is always going to be the number in front of the variable with the biggest exponent. So we've just said the biggest exponent is 3 with the x to the third. Now, what is the number in front of x to the third? Negative 1. And if there's not a number written there, it's understood to be 1. But because of the negative, it would be negative 1. And that's it. So that there is our answer. Standard form and degree and leading coefficient. Okay. So when we look at this here, we need to write it in standard form. So what term would go first? So we're looking for a variable with biggest exponent, which would be 9x to the second, 9x squared would be first. And then what? And it would be negative 2x, because we'll take the sign with it. And then negative 8. So in standard form, this is 9x squared minus 2x minus 8 would be our answer. Now, what would the degree be for this here? 2. The biggest exponent is 2. The biggest exponent is 2. you're getting ahead of, because you're anticipating what I was going to say next. Ask for next. But yeah, so the biggest exponent on those variables is 2, so the degree is 2. Now the leading coefficient would be 9. Because the leading coefficient is always the number in front of the variable with the biggest exponent, which would be 9. Questions on this here? Yep. Okay. Write each one in standard form. Identify the degree and classify each polynomial by the number of terms. Yep, so it's not asking about leading coefficient, but we'll go on and answer it anyways. So when we look at A, we have negative 3z to the fourth. Is it in standard form? Well, yes, there's nothing else being added or subtracted, so it is in standard form. Now, what would the degree be? It would be 4. Because again, we're looking at the exponents. And the only exponent we have here is 4. Now, I didn't ask for this, but let's look at leading coefficient. The leading coefficient would be negative 3. Okay. Now we need to classify it by the number of terms. Well, how many terms do we have? 1. And a one-term polynomial expression would be a what? It would be a monomial. Monomial. Because one term is monomial. Monomial. One term is a monomial. Okay, well, that takes care of the first one. Let's look at the second one. 4 plus 5x squared minus x. Is it in standard form? Well, no, because biggest exponent has to go first. Well, what is the biggest exponent? 2. So our expression with the 2 in the exponent would be our 5x squared. So it has to go first. Now what term would go second? So we had x squared first, so the next lowest one would be our minus x plus 4. A constant term, the term without a variable, will always go last. Now the degree for this here would be 2. The leading coefficient, which you didn't ask for, would be 5. It's the number in front of our x squared. And how would we classify this? Trinomial. Trinomial, because tri means 3. Okay, the last one here. 8q plus q to the 5th. So what would be our first term if we're writing this in standard form? Well, which one of these two has the bigger exponent? It would be to the 5th. So q to the 5th would go first. And well, that really leaves us with plus 8q. Now the degree for this here would be now what would the leading coefficient be? 1. Because since there's not a number written in front of q to the 5th, it is understood to be 1. And we would call this a binomial. Because bi means 2. And that's it. Questions on any of this here? All right.